So now let's look at some word problems, or just an example of a word problem. So for this example, I just took something similar to the textbook and then just kind of changed the numbers a little bit. So for a person at rest, the velocity v in liters per second of airflow during a respiratory cycle, it's the time from the beginning of one breath to the beginning of the next, is modeled by v equals 2 sine of pi t over 3, where t is a time in seconds. Inhalation occurs when v is greater than 0, and exhalation occurs when v is less than 0. So we're supposed to find the time for one full respiratory cycle. So what that is that's one period. We're looking at sine, so one period is going to be 2 pi over b. So we have to identify what b is. B is pi over 3. So then we solve. 2 pi over 3. So 2 pi times 3 over pi, right? You flip and multiply. So therefore, this is 6 seconds. That is one full respiratory cycle. So one cycle, I'm just going to write in words, one cycle in 6 seconds. Now it asks us to find the number of cycles per minute. So that's why I wrote this here. So we have one cycle in 6 seconds. So we need to find the number of cycles per minute. So what we're going to do is, I know that it's one cycle for every 6 seconds. So we need to convert that. Use dimensional analysis. So we know that we need to cancel out the seconds. So there's 60 seconds in each minute. So then we simplify. So seconds cancel. 6 goes into 60 10 times. So we get 10 cycles in 1 minute. Okay, so that'll be very similar to the other word problems. Going to ask for find the time for one cycle, and the second one's going to be find the number of cycles per whatever it asks for, whatever time, and then it may ask you to sketch the graph. So we're going to sketch the graph of the velocity function. We're graphing sine. We know the period is 6 already, so we're going to divide this 1, 2, 3, 4. So I'm going to say this is 6 seconds. Half of 6 is 3. Half of 3 is 3 halves. And then over here, this is going to be 9 halves. Now, our amplitude is 2. So I'll go ahead and put 2 here and -2. We are graphing sine. So sine starts at 0. And then it's going to go up, down, down, up. Okay, kind of just following the parent function. And so here is a graph of the velocity function. And again, we know inhalation occurs when v is greater than 0. So this is the inhalation, and this is the exhalation.